Whenever you add in peptides and transitions in Pinpoint, it will predict the collision energy for those peptides using a very simple formula. This is disabled, but you can see this 0.034 and the intercept of 3.314 for or plus 2 charge state peptides, and for plus 3 it's 0.044 and 3.314. So it would have these numbers, and it will multiply the precursor mass value, which is 576.77, with the slope here and add the intercept to get the predictive collision energy. And so for all 4 transitions in this peptide, it will have the same collision energy. That's how the first method is built. But if we want, we can do better than that and optimize that. So we have 52 peptides in this run. They are doing scheduling, and so you can see this graph. But if you come to export optimization at this point, what it will do is, for every single peptide, it will build a range of collision energy possibilities. So if the predicted energy for a transition is 22 electron volts, we can do a plus minus 6 electron volt window with a step size of 2. So it will go minus 6, which is still 16, and then plus 6, which is still 28, and do 16, 18, 20, 22, 24, 26, and 28. All these 7 possibilities for every single transition. And so we'll do it for each of those 208 transitions that we are monitoring on this window. And so our scheduling will obviously become worse. So in this window, you can see we are monitoring about 30 transitions at any given time. And if we do 7 possibilities for every transition, we are monitoring approximately 210 transitions at any given time. We can choose to split this into 2 runs, and we can export this file to CSV. And I wanted to show you how this file looks like. I'll call it CE_run, and it has generated 2 files, and we'll go and find those. Here's our run 2. Let's open that. And this window is the precursor mass value, this window is the product mass value, and this window is the collision energy. So for example, for this transition, it has built-in possibilities 11, 13, 15, 17, 19, 21, and 23. And it has modified the product mass value just slightly so that it does not affect the data quality, but it will still be able to monitor 7 transitions or 7 possibilities for this transition without any problem. So now we go and run in this method file. We'll get lots and lots of transitions. We come back to our original method file, go to raw file management, and put it in a raw file. So I have the data processed already, and I will just open that. That file will have lots and lots of transitions. So opening that file or processing might take a little bit of time. I did the experiment in triplicate, so you can see there are 3 raw files here that are being added, and so now it has an intensity value for every single transition for 7 possible collision energy values. So that's that really helps Pinpoint in building what is the most optimal collision energy value for all of those transitions. And we'll just wait for the data to load up. Okay, so here's the data, and if you click on any peptide, you'll see lots and lots of transitions underneath that. So you can see in this graph there are so many transitions underneath, and it's eluting at around 3.9 minutes, and all of these transitions are showing up. In this video, we'll be covering the method refinement section of Pinpoint. So we have some peptides and transitions that we're monitoring. We bring in our raw files, and we get the data analysis. So for example, this peptide looks very nice. We didn't see this peptide, it's not there. This peptide has high CVs, or the ratios are not that good. So we get up different colors, And now we need to build our second method, which is possibly a collection of these peptides, a collection of these transitions, better scheduling. All those options can be done inside Pinpoint. So you go to method refinement and optimize, and you first choose what peptides and proteins that you want to keep in your next analysis. So the first way it can happen is just by using colors. You can say I want my green ones, or I don't want my green ones, or I want my yellows, or I don't want my yellow ones. We can do that. So that will basically take only the green and yellow peptides and throw out all the reds. Or this option will take only the red peptides, and then you can maybe remove scheduling by using this, and then try and see if you maybe had the wrong scheduling. So you can do all of these options to get to your right set of peptides. Or you can keep only the green ones and say these are the best ones, let's make a schedule method for only those. And you can define your scheduling window right here. So this selects the peptides. If you don't want to go just by color, you can go back to data analysis and add a particular column called keep in next iteration. Let's remove some other columns so that we can see that. It's added in this table right here. And from then on, we can say which peptides I want to keep. I want to keep this one. I want to keep this one. I don't want to keep this one.